Fran obtained a $50,000 home equity loan at 6.25% compounded monthly. Let's first try to figure out what her monthly payment size is going to be if the amortization period is 15 years. Since we will have to make an amortization table in Part B, let's go ahead and just assume that we're making month-end payments here. We're going to take our principal amount to be a positive $50,000 with our future value to be 0. We have an interest rate of 6.25% compounding monthly, and we know that we're making monthly payments as well. Monthly payments over 15 years gives us 15 times 12, or 180 of these equal-sized payments. Pulling up our calculator and making sure we are in end mode, we're going to start programming in some of our values. So 180 in for n, we need 6.25 for the interest. We can slide into that submenu, ensure that both of these values are programmed in as 12. We have a $50,000 positive value coming to us for the PV, and let's assume our future value will be 0. Computing the equal size payments, we should get $428.71. And notice here that the calculator does give this to us as a negative value because it's showing to us that we will be paying down this loan or giving this amount of money, this payment, to the bank. Next, let's move into Part B. How much of the payment made at the end of the 5th year is going to go towards the principal, and how much is going to go towards the interest? So we're going to have to get down to line 60 of our amortization table. Since we're making monthly payments of $428.71, this means that n is equal to 60 should be the end of the 5th year. This means that we're actually after the balance at line 59. So what I'm going to do is I'm going to take my $428.71. We're going to make that a negative value and program that in for the payment amount. Next, I'm going to input 59 for n. Asking the calculator to compute the future value here should give us about $38,411.07. What we need to do now is we need to take that future value, we're going to make it positive by hitting the plus minus button, and we need to multiply this by our interest rate, which is 6.25% compounded monthly. And I do want to make note here that we don't have to calculate I2 because we are making monthly payments and the compounding frequency is also monthly. Let's write down our $200.06, and then we can subtract this from our $428.71. And that should tell us how much is going to be going towards the principal balance remaining. So about $228.65. Finally, in Part C, we're curious about how much interest she's going to pay in total, and the easiest way to do this with the information we have is to take our value for n, multiply it by the equal size payment, and subtract our principal amount. If the amortization period is 15 years and we're making monthly payments, that means we should have around 180 equal-sized payments of $428.71. The initial borrowed amount was $50,000. And simplifying this expression, we should see that we are expected to pay around $27,167.80 in interest over the term of this loan.